Hey guys, it's IGW, and today we're actually going to be making forward progress in the series and not just doing a whole bunch of virtual stuff. We're going to actually be building something that's going to be able to add 1 to something, and we're not just going to be messing around with logic gates or doing stuff that is sort of requisite skills. Anyways, so the way that we're going to build this is essentially, well, since we already know that the XOR gate, if I was to have an XOR gate right here, if I was to just, first of all, remove that, if I was to just turn that on, then this would be what I was adding. Well, essentially, if I wanted to add 1 to something, and then this was my first bit, then all I would need to do would be to just do that and add 1 to whatever is here. But of course we come across the problem that we need to move it over to the next bit if this happens. So the way that you need to solve that is you need to take this signal, and if this signal is also on, we have to move it over to the next bit. And if that signal is also on, you have to keep moving it on, and so on and so on and so on. So basically, if the bit that we're adding to is on, well, the digit that we're adding to, the technical term is bit. I think I'll start using that from now on. Well, the bit that we're adding to, if its natural value is 1, then we're going to have to carry it over to the next bit as well. Now, one of the tricks that one can use when you're actually building one of these is that you don't just use the AND gate that we have here. There's actually a way to make it really, really, really fast, and that's what I'm going to be doing. And it sort of goes on the principle of having this on is allowing this to pass through. What I'm going to do is I'm going to have the number that I'm trying to add right here, I'm going to have a piston, and on this piston I'm going to send the value of whatever we have in here. Of course it's going to have to be inverted, but whatever. So if we send whatever, so this is basically telling us we want to add 1 to whatever we have. And this right here is our actual bit. So what's going to happen is if this bit is on, it's going to pass it over to the next bit by, and of course I'm derping with pistons. Anyways, so that's actually going to make it so that that will extend. So basically what we have here is if we build another one of these, I think you can sort of see where this is going. We can have this signal go into an XOR, which is going to end up actually doing the addition sequence that we need to do. And then, depending on whether or not these pistons are extended to a point where they can let it they make it so that we have to add 1 to that bit. For instance, if I was to have this one like this, then you would have to move that onto that. If I was to have this like this, you would have to move that onto that, etc., etc. So basically, now we have the value that we need to add to each bit. So now, since we know how to do 1-bit addition, all we need to do is just make an XNOR. And I'm actually going to be using a multiplexer-based XNOR, which we haven't actually been over in this series. All you really need to know is that this acts as an XNOR to learn. By the way, this is not the best XNOR design. It's a really cool one, though, so if you want to use it like that. How exactly do I need to do this? Oh, bugger. Oh dear. Oh dear me, this isn't... Sure, I'll... Fine. Fine, Redstone. Fine, Minecraft. I'll do what you want me to do. So basically, here's where my number is going to come in. And then depending on whatever state this is in, I'm not going to actually do the proof to show that... Oh... That's... Aha... Thought you could fool me, couldn't you, Redstone? Anyways, so... all that really matters at this point is that you understand the logic that's going into this, which I think I've explained pretty thoroughly, that if this is on, that's the only case that it can pass it over to the next bit, and then it's actually going to add it. So, essentially, what this thing should be doing if we stack it a few times is it's going to be able to, whenever we tell it to add 1, it's going to add 1 in binary to it. So for instance, if I was to do 1 plus the example that we have over there, which is 11, we would get a binary 11. It's assuming that this is the least significant bit or digit, and this is the most significant bit or digit. And if we turn this off, then we're going to stop adding to it, and we're going to get our 11 back out. So yeah, sorry if my commentary wasn't the most understandable, but if you get the concept, then I sort of made a really weird way in trying to implement incrementation into this. Normally, if I was making a series or someone was making a series, they wouldn't actually bring this up, but I think that it's something that people should know. And I mean, if you know where I'm coming at from with adders, and you're a fairly advanced Redstone person, then I hope this may have helped you a bit. I don't know how much, but yeah. We're having a whole bunch of fun for prose things in this series, like I was doing the geometrical proofs about stuff and such, but yeah. So now we have our first incrementer. This can actually add 1 to stuff. Sorry if it's a bit confusing. I'll try to make my explanation of adders, which might be a bit easier for me to do, a bit more understandable. But basically, passes the signal through if it's on, and then it uses the XOR, well, XNOR that has an inverted input. I proved that in one other video where I showed that if you invert one of the inputs of an XOR or XNOR, it'll turn into the other. That was in part 3, I believe. So that's what's going on there. So basically I have an XOR of this, so it's adding them together. So yeah, see you guys next time.